Academy.
Yeah, hello guys, how are you all? I hope you guys are doing well. So, by the way, I'm Pavan Kumar, a senior chemistry faculty here. So, I'm very happy to announce you that Harish Academy is going to launch a new batch for JL chemistry here. So, I'm a senior faculty. I would like to tell you some important things about this JL entrance exams here. See guys, here in JL entrance exam, not only JL, for any competitive exams, you know that. What we need. So we need, the simple thing is that we need time. Time for what? The time for competitive exams, in the examination, right? So in that examination, if you use a less time to answer the more questions, yes, you will be the ranker and you will get the job. Correct? So here, myself, one confidently I can say you guys here, whatever the topic it may be in the chemistry, I never follow the traditional method to answer the questions in the competitive exams. So here I'm going to give you most of the shortcuts to answer the questions in the competitive exams confidently within the less time here. So for let me take you one topic here. That topic will gives you some confidence. What model, if any particular model question is there, how to answer that question in the easiest way without taking 10 to 15 seconds. I'm very sure, listen the classes regularly. Guys, you can improve your shortcuts and you can use those shortcuts to answer the questions in the competitive exams, and definitely you will get the job here. Right, let us get into the topic here. So today I would like to tell you something about the absolute configuration and applications of the absolute configuration here. So what are the absolute configurations? Let me tell you here. So the topic is about absolute configuration here. So what is absolute configuration? So the absolute configuration is nothing but see, absolute configuration. Absolute configuration. What is absolute configuration here? So absolute configuration is nothing but RS notation. R or S notation. Notation. So what is RS notation? What is RS notation? Actually, what is the meaning of R and what is the meaning of S? Let me tell you that here. See, R, actually this alphabet R is derived from the word rectus. It is derived from the word rectus. So what is rectus? Rectus means, rectus means it is right hand side it is. Rectus means, right hand side. Rectus means right hand side, or you can also say it as a clockwise. Clockwise. Rectus means right hand side or clockwise. The rotation you can represent the clockwise rotation like this here. Clear? Right. And S, what is the S here? S is derived from sinister. S is derived from sinister. So what is sinister? So sinister nothing but left hand side. Sinister is nothing but left hand side here. So what is left hand side? I will tell you in detail here. Left hand side, or you can say anti-clockwise or counterclockwise it is. Anti-clockwise, or you can say counterclockwise here. So the direction can be represented like this here. So now let me tell you what is R and what is S, in which conditions we have to use, this terminology, and what are the applications of this RS configuration. Let us discuss in detail here. So generally, this RS configuration represents, the spatial arrangement of the atoms or the groups, what it represents here, it represents about the spatial arrangement of the atoms or the groups at chiral center. So first thing you have to remember is that RS configuration is absolutely applicable for the chiral carbon atom. What is chiral carbon? Let me show you that here. So for example, here see guys, let's see this here. So you can see, just suppose consider, at this center a carbon atom is there. Here is a carbon atom, and which is having the 4 bonds, which are present at the tetrahedral corners here. And here you can see, consider, each ball, different color balls are there now. So consider different, why I mentioned the different color balls means, so to show you that, each color is a different group here. So now this is a carbon atom is attached to the 4 different atoms or the 4 different groups here. So the carbon which is attached to the 4 different atoms or the 4 different groups is called as a chiral carbon. Chiral carbon. So chiral carbon, actually the word chiral is there now, it is derived from the chirality. Okay, the word chiral is derived, where from it is derived? It is derived from the chirality. Chirality. So what is the meaning of chirality? Chirality is nothing but handedness. Okay, it is nothing but handedness here. So what is handedness? Let me show you that here. So that's quite simple. For example, if you see this hand, so one hand is here having the how many fingers? Yes, 5 fingers are there here. So now tell me whether all the 5 fingers of this hand are they equal in size or not? Yes, they are unequal in the size. That means one hand has a 5 different sized fingers, right? So that is called as a handedness. Same handedness you can see at chiral carbon. So carbon means, okay, here chiral carbon means here one carbon can form the 4 bonds only, tetravalence it has. So if those 4 bonds are there with the 4 different groups, yes, you can say that is the chiral carbon here. Now, this absolute configuration or RS notation is applicable to the chiral carbon atom only. Okay, absolute configuration is absolutely applicable to the chiral carbon only. Okay, right. So then what is absolute configuration? Configuration, it means what here? Configuration is nothing but the spatial arrangement of the atoms or the groups around the space of the central atom. So now suppose here is a central atom now, here is a central atom. Around the space, okay, the groups are present at the different positions. Okay, the groups are present at the different positions. How they are arranged? That arrangement will be described by using the R and S configuration here. Okay, understood? Right. Now let's see how to assign RS configuration for a chiral carbon atom and what are the applications are there in the absolute configuration and what model questions will be there, how to solve those questions. Okay, let me explain in detail. Okay guys, clear? Right. Let us get into the new topic here. So now here say, okay, let's go to the assigning the absolute configuration. So first you need to know chiral carbon. So what is a chiral carbon here? So chiral carbon. So chiral carbon. So chiral carbon nothing but the carbon which contains of 4 different atoms or groups here. So chiral carbon is that so which contains 4 different atoms or groups. Okay, this is called as a chiral carbon here. Okay, and the spatial arrangement of these 4 different atoms and groups can be represented with the absolute configuration. How to do that here? So whenever you are assigning the absolute configuration, you have to remember 2 things here. It means there are the 2 steps to assign the absolute configuration here. So what are the 2 steps here? So whenever you are assigning the absolute configuration, here, let me explain that here. So assigning absolute configuration, which configuration? Absolute configuration here. Okay, absolute configuration. So whenever you are assigning the absolute configuration, what you have to do is that you have to follow the 2 steps here. So what are the 2 steps here? So first step is that so give the priority to the 4 different groups here. Okay, so 4 different groups are there now. So for example here, first let me explain theoretically how to do that here. So for example, if you take this molecule, whatever the molecule it may be, so how to assign the absolute configuration? First let me tell you the textbook methods which you are following here. So consider this is a chiral carbon which is having the 4 different atoms or the groups here, correct? Now what we have to do? So we have to give the 1, 2, 3, 4 priority. 4 groups are there, so you give the 1, 2, 3, 4 priorities here. Okay, how to give those priorities means, yes, we have to follow some rules. Yes, absolutely we have to follow some rules here. So when you follow those rules, you can give the priorities. After giving the priority, what to do? So let me tell you one thing here. So for example, see, I am holding the molecule like this here. Consider, this is the first priority group here. Green color is the first, and this is the second, red color is the second, and this pink color is the third priority, and back side, one more group is here, yellow color is the 4th priority. Okay, now, so do you remember here? 1, 2, 3, 4 priorities are given here. That is the first step. In the first step, you guys have to give the 4 priorities to the 4 different groups. That's it. What is the second step here? Now what you have to do is that, from the opposite side of the 4th priority group. Now here back side is a 4th priority group is there now. So with respect to this 4th priority group, you have to observe the molecule in the opposite direction. That means if the 4th priority group is there on the back side, you have to view the molecule from the front side here. Understood? Or in case if the 4th priority group is there at the top, you have to view the molecule from the bottom side. If the fourth priority group is here on the front side, you have to view the molecule from the back side here like this. What we have to do is that after giving the priorities, just view the molecule from the opposite direction of the fourth priority group. Now check how the priorities going, how the priority groups are arranged here. Now here see, this is the first prioritized group here, and second, first to second you have to observe, first to second and second to third. First to second, second to third. How is our I direction is rotating? Yes, our I direction is rotating in the clockwise manner. Correct now? So I direction is rotating in the clockwise manner from first to second, second to third. I direction is rotating in the clockwise manner. Whenever the I direction is rotating in the clockwise manner, when we observe from the back side of the fourth priority group, so that clockwise is nothing but rectus. So you can say the carbon atom is having the R configuration. That's it, simple. In case, so now let me change the positions of the groups here. Let me change the positions of the groups. Now you guys can see that here I said that the green color is the first priority group and red is the second, and this one is a third priority group. Now view the molecule from the first to second, second to third. How is our I direction is rotating? Anti-clockwise manner. It is anti-clockwise manner here. So whenever the I direction is rotating in the anti-clockwise manner, and you have to, this compulsory condition, you guys have to observe the molecule from the opposite side of the fourth priority group. In that case, clockwise rotation represents R configuration, and counterclockwise or anti-clockwise represents S configuration. It is here. This is what we have to do. Understood now? Now, let me tell you. The important thing is that how to assign the priorities is an important thing. Let me give you the clear idea. How to assign the priorities. So, to assign the priorities. Give the priorities. Assigning or giving priority here. So whatever. Whatever you can say. You can write it like this here. Giving priority. Giving priority. Let's see how to give the priority. So to give the priority, we have to follow the rules. What are the rules we have to follow? So we have to follow some rules here. The rules are they are called as the SIP rules here. Let me tell you that. What are the SIP rules? Guys, fine. We have to follow SIP rules. CIP. Con Ingold Prelog rules. SIP rules are these here. So what are the SIP rules you have to follow? Let me tell you that here. So the first SIP rule, is nothing but atomic number rule here. The first rule is here now. The first rule is called as a atomic number rule. Which rule it is? Atomic number rule here. Atomic number rule. What is atomic number rule? What to do with the atomic number rule here? Let's see that here. Now suppose guys here, see, let me take you one of the simplest example here. So I'm writing a molecule like this. Consider, here I'm taking the some random molecules. For example, here I'm writing the CH3 methyl group, and I'm writing the one hydroxy group, and here I can write something like fluorine, and let me write NH2. Now you can check that here. First you have to check that whether the given carbon is a chiral or not here. Yes, this is a chiral carbon. This carbon is a chiral carbon because this carbon is directly attached to the 4 different atoms or the groups here. Hence it is a chiral carbon. Next, what to do? What to do here? Now guys here see. What to do? Is that according to atomic number rule. According to atomic number rule, what you have to do is that, so whatever the chiral carbon is here, you have to check all the 4 atoms which are directly attached to the chiral carbon. Now here see, this is a carbon. Above this side carbon atom is here. Now on right side oxygen oxygen atom is here, and below this side fluorine atom is here, and the left side nitrogen is here. Guys, I'm reminding you again, you have to check the atoms which are directly attached to the chiral carbon. Those atoms first you have to take here. Now here see what to do. Just take the atomic numbers. Check the atomic number. What are the atomic numbers? And all we know that. Suppose if you see that, atomic number of the carbon is a 6, oxygen 8, fluorine 9, and nitrogen 7. Right. So after giving the atomic numbers, next what you do, that's quite simple here. What you have to do is that the atom or the group, the atom which has the highest atomic number gets the highest priority, And as the atomic number is decreasing, the priority also decreases here. That's all quite simple here. Here see, so here 4 atoms are there. So you have to check which atoms atomic number is more. Yes, okay, carbon 6, oxygen 8, fluorine 9, nitrogen 7. So fluorine atomic number is the highest among the 4. So therefore the fluorine gets a first priority. Okay, fluorine gets the first priority. Okay, well, right. So next up, okay, it gets a first priority. Okay. First priority. Next, whose atomic number is more? Oxygen. So oxygen gets a second priority. Give that. Next, okay, 6 and 7 is here. Nitrogen is here. Nitrogen atomic number is the next highest priority. Next, highest atomic number. So therefore, it gets the next highest third priority, and carbon gets a fourth priority here. Okay. So this is the first thing you have to do. Okay. Now, so I said that. Okay, give the priorities. Okay, 4 priorities to the 4 different groups here. Okay, based on which condition you are giving atomic number rule here. So the atom which is directly attached to the chiral carbon with the highest atomic number gets the highest priority. And as decreasing the atomic number, what happens? Priority also decreases here. Okay, done. After giving the priority, what to do? Okay, I told you now, we have to view the molecule from the opposite side of the fourth priority group. Okay, so then view the molecule from the first to second, second to third. Then what happens? If our I direction is a clockwise manner, yes, that is called as a R configuration. If it is a counterclockwise manner, S configuration. Okay, that's fine. So if you have, okay, the molecule is represented like this in the 3 dimensions, yes, that will be easy. But here it is a 2 dimensions diagram only. Okay, because the molecule is represented along with the only 2 axes. Okay, 2 axes it is represented, so it is a 2 dimension. In that case, okay, how to do that here? Actually, guys, okay, let's see. Okay, whenever you are representing the molecule by using the one vertical, okay, and a horizontal lines, okay, that is called the Fisher projection formula. So what is a Fisher projection formula means? How? Okay, so generally representation, okay, of the organic molecule is in the different manners. So in which, okay, one parent chain will be there now. So you have to represent the parent chain with a vertical line. Okay, the vertical line represents all the carbon atoms of the parent chain. Later, the most oxidized groups at the 2 terminals will be there now. In the parent chain, 2 terminals will be there. So the most oxidized group should be at the top. Okay, at the top of the vertical line, and another, okay, the terminal will be at the bottom. And in between these 2 terminal carbon atoms, okay, non-terminal carbons are there now. So the bonds at the non-terminal carbon atoms will be represented on the horizontal line. Okay, that is called the Fisher formula here. Okay, fine. So, okay, this is a Fisher projection formula. In this Fisher projection formula, then what to do here? Okay, what to do? How to assign the absolute configuration? Let me tell you one simple shortcut here. So what's the shortcut you guys have to follow is that? Okay, let me tell you the shortcut. Okay, to assign the absolute configuration, okay, in the Fisher projection formula. Okay, that's quite simple here. Okay, guys, here remember. Okay, remember in Fisher formula. Okay, in Fisher formula. Okay, in Fisher's formula. What to do? Quite simple. See, this is a vertical line and this is a horizontal line. Okay, so here I am telling you the simple rule here. Okay, vertical is very good, horizontal is opposite here. That means if the 4th priority group, okay, if the 4th priority group is there on the vertical line, okay, that is one possibility is here. So the 4th priority group may be on the vertical line. It may be on the vertical line means it may be on the top or bottom, anywhere, but you have to check whether the 4th priority group is on the vertical line or not. Okay, now, so if the 4th priority group is there on the vertical line, what absolute configuration we can give? And in the same manner, what if the 4th priority group is there on the horizontal line here? Okay, let me tell you that here. So, I am giving you the 2 conditions. Okay, one is the presence of the 4th priority group at the vertical line. Another one is the presence of the 4th priority group on the horizontal line here. Okay, now, right. Let's see next here. So, if the 4th priority group is on the vertical line, and suppose, okay, here see, if the rotation may be in the clockwise or rotation may be in the counterclockwise or anti-clockwise directions. Correct now? Right. Now, guys, here remember, if the 4th priority group is there on the vertical line, okay, if the 4th priority group is there on the vertical line, the clockwise rotation, okay, clockwise rotation represents it as a R configuration. Okay. And if the 4th priority group is on the vertical line and anti-clockwise or counterclockwise rotation represents it as a S configuration. And whenever the 4th group is there on the horizontal line, it should be the opposite. It should be opposite. That means, okay, whenever the 4th group is there on the horizontal line, the clockwise rotation is represents a S configuration, and anti-clockwise rotation represents R configuration here. So this is what you guys have to remember. So for this, okay, let me tell you the simplest shortcut here. What to do, how to remember this here. So simply remember, generally we know, okay, if the priority, okay, the R is derived from the rectus. Rectus means clockwise, correct? Now rectus means clockwise here. So here clockwise is a R, anti-clockwise is a S. Okay, S is derived from the sinister. When it is correct means whenever the fourth group is present on the vertical line, that is correct. That means vertical is very good. Vertical is very good. That means, so which represents a clockwise direction is a R, counterclockwise direction is a S. Okay, na? And whenever the fourth group is on the horizontal line, okay, whenever the fourth group is in the horizontal line, horizontal is opposite. Remember like that, horizontal is opposite, vertical is very good. So horizontal is opposite means clockwise becomes opposite. Okay, generally clockwise is a R, but opposite is a S. So horizontal is opposite. So whenever the fourth group is in the horizontal line, the clockwise rotation from the 1 to 2, 2 to 3, okay, is in the clockwise manner. Okay, that represents a S configuration, and the anti-clockwise rotation represents a R configuration. This is what you have to remember. Clear? Now let us apply this concept to here. So if you apply that concept, here guys, here see, the priorities are already given here. So priorities are already given. So fluorine has a first priority, okay, among the 4. So the first priority group is there at the bottom, correct? The first priority group is there at bottom here. So let me use a different color pens because chemistry is colorful, right? Okay. So here I am writing the first group here, first priority group here. Next, second priority is there towards the right side, correct? And third priority, nitrogen containing, is there towards the left side, and methyl, fourth priority group, is there at the top, above the side here. That's it. Okay, 4 priorities are given. After giving the 4 priorities, okay, after giving the 4 priorities, what to do here? View the molecule from the first to second and second to third here. Forget about the fourth group here. Okay, here is the fourth group is here. Forget about it here. Then view the molecule from the first to second. Okay, and second to third. That's it. Okay, forget about the fourth group here and view the molecule from the first to second, second to third. So from first to second and second to third, how is our I direction is rotating? Our I direction is rotating in the anti-clockwise manner. And where is the fourth group here? The fourth group is here on the vertical line. So 4 by V rule. So 4 by V rule means, okay, whenever the fourth group is here on the vertical line, the anti-clockwise rotation represents it as a S configuration. Yes, that's all. So you can say now the carbon atom, that chiral carbon atom is having S configuration. Like this you can finalize. Quite simple, right? So here once again I am reminding you what to do. The first thing is that give the 4 priorities to the 4 different groups present at the chiral carbon. How to give the priorities? The first rule is that atomic number rule. According to atomic number rule, so the atoms which are directly attached to the chiral carbon atom, okay, at first you have to check the atomic numbers of the atoms which are directly attached to the chiral carbon atom, correct? So later you have to check their atomic number. The atom which has the highest atomic number gets the highest priority, means the first priority. And as decreasing the atomic numbers, the priority also gradually decreases here. Like that, give all the 4 priorities to the 4 different groups. Okay. And if the molecule is represented in the Fisher projection formula, how to assign the absolute configuration? It means what to do is that, so whenever the molecule is representing in the Fisher projection formula, just to follow this chart. Okay, simple shortcut it is here. What to do here? So you have to check that whether the fourth group is here on the vertical line, irrespective of the position, whether it may be above or below, that is secondary. You have to check at which position it is present here, whether it is at above the side or below the side here. Or if the fourth priority group is here on the horizontal line, means you have to check whether it is on the right or left side, wherever. Whether it is present on the horizontal line is there or not, that is only important. Yes, next step. So after giving the priority, okay, just check the where the fourth priority group is here. Next, view the molecule from the first to second, second to third here. Okay, first to second, second to third, you have to check the molecule. Okay, and you have to observe how is our I direction is rotating, whether it is rotating in the clockwise or counterclockwise manner. Okay, so after checking the direction of the rotation of our I, okay, from the first to second, second to third, check the based on the fourth priority group position, you can assign the absolute configuration here. So in this particular molecule, so from the 1 to 2, 2 to 3, okay, the I direction is rotating in the counterclockwise manner, and fourth group is here on the vertical line. So vertical is very good, so that means anti-clockwise represents a S configuration. Yes, you can say the carbon atom has a S configuration here. Clear now? Understood? Right. Now let us go to the second rule here. So this is the first rule only I told. So what is the second rule here? So the second rule is that, Okay, the second rule is, okay, is also nothing but atomic number rule only, but extension of atomic number rule. What is the extension of atomic number rule? Okay, this is a part of atomic number rule. Okay, for example, you guys, okay, if you see this is a molecule, what I am doing is that I am giving the different, okay, the groups here. Okay, for example, consider, okay, this is a molecule. In this molecule, okay, in this molecule, let me write some different groups here. So, for example, let me take CH3 here, and let me take a hydroxy group here, and let me take hydrogen here, and CH2CH3. So, these are the molecules I am taking here. Okay, the different groups are there in this molecule here. Okay, and yes, we know that, okay, this carbon is a absolutely chiral carbon atom because it is attached to 4 different groups. So, chiral carbon. Now, let us see how to assign the absolute configuration to this chiral carbon. Okay, follow the same thing. Okay, at chiral carbon atom, okay, at chiral carbon atom, check what are the 4 different atoms are directly attached here. At chiral carbon atom, you can check that here. Okay, at the top side, 1 carbon atom is there. Okay, right side, carbon is directly attached to oxygen, and below the side, it is attached to 1 more carbon atom. Left side, hydrogen atom is there. Understood? Right. Now, what to do? Check the atomic numbers. That's it. Okay, atomic numbers. So, what are the atomic numbers? Okay, let us write their atomic numbers here. So, if you write their atomic numbers, okay, if you write their atomic numbers, yes, carbon atomic number is 6, oxygen atomic number is 8, again 6, okay, hydrogen atomic number is 1. Now, see, okay, I told you that, okay, the atom with the highest atomic number, okay, gets the highest priority. Oxygen atomic number is a more. So, oxygen containing group will get the first priority here. So, where it is towards the first side, okay, right side. So, this is the first priority, right side group here. Okay, next hydrogen atom is the least priority among the 4, okay, least atomic number is here. So, it gets the least priority here. So, that hydrogen is there at the left side. So, directly you can say it is a 4th priority group here. Okay, now, and next come to the point, okay, carbon atoms. Sir, here we know the carbon atomic number is 6. Both the atoms are in the same atomic number. So, here how to decide the priority in that case here? So, with this, at this stage you cannot decide the priority. Correct? At this stage you cannot decide the priority. Then what to do? Yes, you have to go through the next further atoms which are present on that here. So, for example, here see, okay, here this is a carbon, this is also carbon having the same atomic numbers. Sorry. So, here you cannot decide the priority. Then in that case what to do? Just go for the further atoms. So, this carbon is again directly attached to the 3 hydrogen atoms. So, just write them here. The carbon is directly attached to the 3 hydrogen atoms. Okay, just write them here, hydrogen, hydrogen and hydrogen. Okay, now next. So, below the said carbon is here. So, this below the said carbon is attached to, directly attached to which atoms here? So, 2 hydrogens and 1 carbon, right? So, write them here, 2 hydrogens and 1 carbon atom here. Okay, fine. Next, what to do is that, sir, here simple, okay, whatever the atoms with the same atomic numbers, okay, must be cancelled because the atoms with the same atomic numbers are not going to help us to decide the priority. So, cancel them. So, here see, here 3 hydrogens, here 2 hydrogens. So, out of the 3, 2 hydrogens you can cancel. Correct? You can cancel the 2 hydrogen atoms. Next, what are the different atoms are left? Okay, at this carbon atom, okay, this carbon atom, 1 hydrogen and here 1 carbon atom is there. So, whose atomic, next again check the atomic numbers. So, check the atomic number. Hydrogen atomic number is a 1, carbon atomic number is a 6. So, now, okay, the carbon atomic number is the highest compared to the hydrogen. So, therefore, this carbon containing group gets a next highest priority. And where it is present below the side now. Right, it presented the below the side now. So, next highest priority, after first next highest priority is a second priority. So, therefore, second priority goes to carbon, this CH2 CH3 group here, and third priority goes to this methyl group here. That's it. So, priority is given. After giving the priority, what to do? As usual. So, after giving the priority, okay, what to do is that, okay, that is quite simple here. Okay, same thing. So, just check that here. Just check that here. So, right side first priority group, correct? Okay, below this side second priority group, above this side third priority group, and the left side fourth priority group is there. Now, view the molecule from the first to second and second to third. Okay, view the molecule from the first to second, second to third here. So, whenever view the molecule from the first to second and second to third, forget about the fourth priority group, wherever it is, just forget it, okay, now, right. So, view the molecule from the first to second, second to third. How is our I direction is rotating? Yes, our I direction is rotating in clockwise manner, correct now? I direction is rotating the clockwise manner. Next, what to do here? Just check the position of the fourth priority group. Where the fourth priority group is present here? Fourth group is present on the horizontal line. I told you now, horizontal is opposite here. 4 by H rule you have to follow. So according to 4 by H rule, okay, since the fourth priority group is there on the backside bond, sorry, not backside, on the horizontal line, okay, fourth priority group is there on the horizontal line. So in general, clockwise is R, but horizontal is opposite. That means it becomes S configurated carbon atom. That's it. That's it. Okay, you can do it here. Understood now? Easy now. So once again, I'm saying here. So here in this case, okay, in this rule, okay, what you have to focus is that, okay, if the two same atoms are there at the at different positions, their atomic numbers will be same. In that case, how to decide the priority? In that case, what to do is that you just simple go for the further atoms. Okay, check their atomic numbers. The atoms with the same atomic numbers at the two different atoms, cancel them because they are not gonna help us, okay, to decide the priority. Correct? So just cancel them and check the other atoms. Sir, again, if the same atoms are there, next what to do? Again, go for the further atom. Just keep on move until you decide the priority. Okay, keep on move until you decide the priority. Okay, now. So later, okay, at particular stage, yes, definitely there will be the two different atoms. So based on their atomic numbers, give the priority set. That's all. Okay, that is what you have to focus in the second rule here. This is extension of atomic number rule. It is same as first rule only, but some extension here. Okay, clear? So after giving the priorities, as usual, okay, view the molecule from the first to second, second to third. Okay, forget about the fourth priority. Okay, view from the first to second, second to third. Just observe how is your eye direction is rotating. If it is in the clockwise or counterclockwise. Okay, you just check that here. Later, where the fourth priority group is existing. So if the fourth priority group is existing on the vertical line, clockwise is a R, counterclockwise is a yes. If the fourth priority group is existing on the horizontal line, clockwise is a yes and anti-clockwise is a R configuration. That's all you can decide it here. Okay, clear? Right. Now let me tell you the third rule. Okay, third rule. Two more rules are there. Okay, let me tell you what is the third rule here. So if you go to the third rule, okay, that is called as a multiple bond rule here. Okay, that is called as a multiple bond rule. What is multiple bond rule here? Okay, multiple bond rule. Okay, multiple bond rule. What is multiple bond rule here? Now, for example, consider here I am giving you one molecule. Okay, in this molecule here I am writing one aldehyde group. Okay, here I am writing one hydroxy group. Here I am writing one hydrogen atom. And here I am writing, okay, CH2OH. Okay, right, good. So what is the name of this molecule? Yes, this is called as a glyceraldehyde. Okay, glyceraldehyde, in which this carbon is a chiral carbon, right? This carbon is a chiral carbon atom here. Now we have to assign the absolute configuration of this carbon. So what to do here? Just give the priorities. Okay, just give the priorities here. How to give the priorities? Okay, let us check that here. Okay, how to give the priorities? Let us check that here. So same as atomic number rule. Okay, let us simplify. Directly let us do here. Chiral carbon directly attached to the oxygen, carbon, hydrogen. Among the four directly attached atoms, oxygen atomic number is the highest. So therefore, oxygen containing this group gets a first priority. And in the remaining three, hydrogen atomic number is the least. Therefore, it gets the least priority. That is the fourth priority. Next, what here? Next, two carbon atoms are there. Okay, so at this chiral carbon atom, okay, two carbon atoms are there. Above this side one carbon and below this side one carbon is there. In that case, what to do? Just go for the further atoms. Go for the further atoms here. See, at below this side carbon, okay, this carbon is attached to two hydrogens and one oxygen. Correct now? It is directly attached atoms only you have to consider. So this carbon is directly attached to two hydrogens and one oxygen. Just write them here. Okay, it is attached to the two hydrogens and one oxygen. With all the atoms, it is having the single bonds only. Okay, now done. And this above this side carbon, aldehydic carbon atom is attached to one oxygen with a double bond and one hydrogen with a single bond here. Now, here oxygen is having the double bond. At above this side carbon, oxygen is having the double bond with the carbon. In that case, that double bond or triple bond are called as a multiple bonds here. So if it is there with a double bond, okay, if it is there with a double bond, what to do is that you have to consider the oxygen is existing twice. Okay, what you have to do? You have to consider the oxygen is existing twice. 2 times oxygen is existing. If any other atom, suppose if you take the nitrogen may form the triple bond. So, so if any other atom is there, okay, having the triple bond, you have to consider that particular other atom is existing for the thrice, 3 times. Like that you have to consider it. So in case if the multiple bonds are there, what to do here? So you have to consider that neighbor atom, okay, existing equal number of the times of the bonds present in that okay, atom here. That's all, quite simple. So here, since oxygen is having the double bond, okay, you have to consider, okay, here it is okay, here oxygen is existing the twice. So that is the reason why I am writing this oxygen for the 2 times. That's all, quite simple. Clear? Right. Now cancel, same as cancel the same atoms. Okay, hydrogen get cancelled, oxygen get cancelled. Okay, because their atomic numbers are the same, so that they are not going to help us to decide the priority. Next, different atoms are there. What are the different atoms here? Here is hydrogen and here is oxygen. Now check their atomic numbers. Oxygen atomic number is a 8, whereas hydrogen atomic number is a 1. So since this oxygen is having the highest atomic number, that oxygen containing the group gets a next highest priority. Understood? So what is the next highest priority here? So okay, hydroxy group first priority is done. So next highest priority is the second priority. Yes, it will get the second priority, and here it gets the third priority. That's all, guys. Okay, first step is done. First step is done. That means 80% of the work is done. Next is simple here. You just view the molecule from the first to second, second to third. Okay, by forgetting the fourth priority group here. So directly let me do that here. So first to second and second to third, our I direction is rotating in anti-clockwise manner, and whereas the fourth priority group is here in the horizontal. In general, anti-clockwise is a yes, but horizontal is opposite. Horizontal is opposite means here, okay, since the fourth priority group is here on the horizontal, okay, fourth priority group is here on the horizontal, okay, 4 by H rule, I told you that. Okay, horizontal is opposite. That means anti-clockwise is generally S, but opposite means becomes R. So this is having the R configuration. Okay, this is called as a multiple bond rule here. Understood now? If the multiple bond is there, what to do, how to decide the priority means, okay, just check, okay, that neighbor atom is having the how many multiple bonds with the, okay, how many times it is having the bond with the carbon. If it is having the double bond, you have to consider that neighbor atom is existing for the twice. If it is having the triple bond, you have to consider, okay, that neighbor atom is existing thrice. That's all, simple. Okay, and it's same as, okay, further, okay, go to the atomic number rule, you can decide the priority here. This is the third rule here. Okay, now let me tell you the last rule. Okay, that is the fourth rule here. So what is the fourth rule? Fourth rule is called as a isotopic rule here. Okay, the fourth rule is called as a isotopic rule. What is isotopic rule? Let me tell you that here. Isotopic rule means in case of isotopes are present, okay, for example, consider here is a molecule like aldehyde. Okay, aldehyde. Okay, and here I am writing something like deuterium, and here I am writing something like hydroxy, and here I am writing the hydrogen atom here. Yes, you can check that here. Okay, let's see how to give the priorities. Okay, so guys, here see what we can do is that. So first you have to check whether the chiral carbon is there or not here. Of course, okay, this carbon is a chiral carbon because it is having the 4 different atoms here. Chiral carbon is there. And what are directly attached atom? Above the side carbon, right side deuterium, below the side hydrogen, and left side oxygen. Among the 4 whose atomic number is a more, oxygen atomic number is a more. So this oxygen containing hydroxy group gets a first priority. Next highest atomic number is there for the carbon. So carbon containing aldehyde group gets a second priority. And here we have the 2 isotopes. Atomic numbers are the 1 only. But okay, no, there are no further atoms. Atomic number is a 1, same atomic number is the same. Then generally we will go to the further atoms, so there is no further atoms. And in case we will, okay, multiple bonds are there, we can check that that is also not there here. In that case, how to give the priority here? Quite simple here. Just check their mass number, atomic mass here. So atomic mass of the hydrogen H11 protium it is. You are writing the hydrogen means it's a protium, hydrogen isotope. Okay, and this is a H12, that is nothing but deuterium. So in case of the isotopes, the isotope which has the highest mass number gets a highest priority. Okay, the isotope with the highest mass number gets a highest priority here. So here you can see, okay, the deuterium isotope, okay, deuterium isotope mass number is a more, so it gets the next highest priority. First, second completed. So what is the next highest here? Third. So the deuterium gets a third priority, and the hydrogen H11 is called as a protium, which gets a fourth priority. That's all. Okay, work is done. 80% work is done here. Now view the molecule. Okay, from the first to second, second to third. Forget about the fourth. Just view the molecule. Okay, just view the molecule from the first to second and second to third here. So from the first to second and second to third, our I direction is rotating in the clockwise manner, right? Okay, our I direction is rotating in the clockwise manner, whereas the fourth group is here on the, okay, vertical line. So whenever the fourth group is here on the vertical line and clockwise direction represents, okay, clockwise direction rotation represents it as a R configuration. That's all. Vertical is very good. So clockwise rotation is a R configuration. That's all, guys. Okay, just follow these rules here. Okay, you can you can assign the absolute configuration accurately without fail in case of Fisher projection formula. Okay, in case of the Fisher projection formula, you can do that here. Okay, let me remind you all, okay, one by one here. Okay, how to okay, give the absolute configuration means, okay, here see, absolute configuration, assigning the absolute configuration, you can see that here the first step is that giving the priority here. Okay, how to give the priority? Okay, I told you that. So guys, whenever you see here what is actually absolute configuration, RS notation. RS notation is applicable to the only chiral carbon atom, first thing to remember. And what is R? R is derived from the rectus, it means right hand side or clockwise manner. What is S? S is derived from the word sinister, it means left hand side and anti-clockwise manner here. And this RS configuration is applicable to the only chiral carbon. The chiral carbon means the carbon which contains 4 different atoms are the groups here. Actually the word chiral is derived from the chirality. Chirality means handedness. I told you handedness means, okay, hand has 5 different sized fingers, same as a carbon contains 4 different, okay, different atoms are the groups. Okay, so next you can see that here. Okay, how to assign the absolute configuration means 2 steps will be there. First step is giving the priority. How to give the priority means just follow the SIP rules here. What are the SIP rules means? First is the atomic number rule. According to atomic number rule, okay, the atom which is directly attached to the chiral carbon with the highest atomic number gets the highest first priority, and as decreasing the atomic number, priority also gradually decreases. Okay, now right. And after giving all the 4 priorities, okay, in the Fisher projection formula, you have to check the 4th priority group where it is present, okay, where it is present, whether it is present on the vertical or horizontal line. If the 4th priority group is there on the vertical line, the clockwise rotation represents R and anti-clockwise represents a S configuration. And if the 4th priority group is there in the horizontal line, clockwise represents a S, anti-clockwise represents a R configuration. Just remember it has a vertical is very good, horizontal is opposite. That's all quite simple here. So yes, as per the given rules, I told you this configuration here. Next, second rule is that, okay, what is the second rule? Okay, extension of atomic number rule. If the 2 same atoms are there, okay, with the same atomic numbers, okay, how to decide the priority? Here at this stage you cannot decide the priority. So to decide the priority, you have to go for the further atoms here. Okay, just keep on move, okay, until you decide the priority by using this formula here. Next, what to do here? Okay, another rule is a multiple bond rule. If any atom is having the multiple bond, okay, then what you have to do is that whatever the neighbor atom is here, okay, if that neighbor atom is having the double bond, you have to consider the neighbor atom is existing for twice. If the neighbor atom is having the triple bond, okay, that is existing for the thrice. Okay, like that you have to decide. Okay, and later, okay, based on the atomic number rules, okay, that means, okay, cancel the same atoms at the 2 different carbon atoms. And whatever the 2 different atoms are there, based on their atomic numbers, okay, you can decide the priority. Okay, this is the third rule. And 4th rule is that, okay, isotopic rule. In case at the chiral carbon, if the 2 different isotopes are there, so isotopes are there which are different at the top mass number, right? So since the mass number is different, okay, that mass number will going to help us to decide the priority. How means, okay, the isotope with the highest mass number gets the highest priority. Okay, based on that give the priority, and again view the molecule from the first to second, second to third by forgetting the 4th priority group, and check the position of the 4th priority group whether it is a vertical or horizontal. Okay, based on that follow the table which I given. Okay, you can answer the absolute configuration here. Okay, up to that it's good. Next, let me tell you, okay, how to decide the absolute configuration if the molecule is represented in the wedge flying formula. Okay, if you know this, okay, that is quite simple here. Let me tell you, okay, in the wedge flying formula here. So what is wedge flying formula? Let me tell you that here. So wedge flying formula, okay, wedge flying formula means you guys can see that here. So this is a molecule now. In this molecule, okay, 3-dimensional representation. Wedge flying is nothing but 3-dimensional representation. What you do is that, so at chiral carbon atom, you have to imagine one plane. You have to imagine one plane here. You see, okay, consider, okay, that plane must, okay, there is a condition. The plane must passes through the center of the molecule, means at the chiral center. Okay, it must passes through the chiral center. And it must possess any 2 bonds. It must possess any 2 bonds. Okay. Now let me imagine one plane. Okay, through this green and the pink color bond here. So I'm imagining one bond like this here. So okay, now just plane. Okay, just imagine one plane in this direction. Okay, this plane is consist of the 2 bonds now. Yes. Okay, this is an imaginary plane, and the bonds, okay, which are, okay, whatever the 2 bonds are lies in the imaginary plane. Okay, imaginary plane called as a normal bonds here. And with respect to this plane, okay, this red color ball means the bond with the red color ball is existing front side now, that is called as a wedge bond, and which is existing back side is called as a flying bond here. So we are going to represent the molecule by using the wedge and flying bonds. Okay, wedge and flying bonds, therefore that is called as a wedge flying representation. Okay, let me show you that how to do that. Okay, that is quite simple. Okay, for example, so in case of the wedge flying, okay, wedge flying, okay, formula. In case of the wedge flying formula, what to do? Okay, let me show you that here, how to do that here. For example, consider this is a carbon atom. Okay, it has a two normal bonds. Okay, the normal bonds are nothing but which are lies in the plane, which are lies in the imaginary plane here. Okay, and the next okay, wedge bond is here. Okay, wedge bond is here. Generally you can represent the wedge bond with a wedge line, thick line. Okay, simply you can say it is a wedge bond. Okay, thick line. If you represent it like this here, okay, that is called as a wedge bond here. And backside bond is here. The backside bond must be represented with a dotted line like this here. Okay, dotted line. Okay, one, right. Sorry guys. Okay, this is a wedge bond and this is dotted line, flying bond here. So this is the front side bond. Okay, what is this here? This is a front side bond it is. Okay, front side bond it is. Front side bond is nothing but wedge bond. Okay, this is nothing but wedge bond here. And this is a flying bond. Okay, this is a flying bond. So the flying bond, okay, flying bond is always exist backside. Okay, backside of the imaginary plane. Okay, flying bond is nothing but the backside bond it is. What is this? This is a backside bond. Okay, that's all simple. If you know this, okay, assigning absolute configuration is a quite simple. Okay, what to do, you know guys here? So that is quite simple. Okay, whenever the molecule is representing in the wedge flying formula, okay, if the chiral center is present in that, how to assign the absolute configuration? Let's check that here. So now here see, give the priorities. Okay, give the priorities 1, 2, 3, 4 priorities. You have to give first here. After giving the priorities, okay, after giving the priorities, okay, what you have to do? Okay, how to check? Okay, how to check where the fourth priority group is existing? Okay, where the fourth priority group is existing. So here 3 possible positions are there to exist a fourth priority group here. Okay, for example, consider here. Here, consider. I am giving the priorities like this here. 1, 2, 3, 4. That's it. Simple. Okay, now what do you do after giving the priority? How to view the molecule from the opposite side of the fourth priority group now? Yes, but okay, of course it is there on the back side, so directly you can see from the front side, you can assign the priority. But if it is on the front side, if it is at the top, if it is there at some other place, how you can see? That will be difficult. So here let me tell you one simple shortcut what to do. The shortcut is that if the fourth priority group is there on the back side bond, okay, follow the 4/B rule. If the fourth priority group is there on the front side bond, okay, follow the 4/F rule. If the fourth priority group is there on the normal bond, I will tell you how to do. Okay, that is quite simple here. So if the fourth priority group is there on the back side bond, okay, fourth priority group is there on the back side bond. So and if the, okay, our right direction is rotating in the clockwise manner, or it may be rotated in the counterclockwise manner. So then what to do, you know? Okay, that is okay, very easy guys here. So here what to do is that whenever the fourth priority group is in the backside bond and the clockwise rotation represents a R configuration, anti-clockwise rotation represents a S configuration. That's all. Okay, if the fourth group is on the back side, the clockwise is a R, anti-clockwise is a S. And if the fourth group is there on the front side, it will be reverse. That means reverse means clockwise represents a S configuration, anti-clockwise represents a R configuration. That's all, quite simple. Just to follow this, okay, the table, yes guys, okay, this simple, the shortcut it is, okay, if you follow this shortcut, yes, you can answer the RS configuration even in the wedge flying formula. Then how to give the priority means follow the same SIP rules here. Just follow that and assign the priority. After giving the priority, just check the fourth group whether it is a okay front side or back side. Okay, this is a front side. Okay, this is a front side bond. I told you wedge bond is a front side bond, and dotted bond is in a dotted line. Okay, that is a flying bond is a back side bond here. Just to follow that here. Okay, let me give you. Okay, for example, let us see this here. Okay, here, okay, just to forget the fourth priority group and view the molecule from the first to second and the second to third here. So view the molecule from the first to second, second to third. Okay, first to second and second to third. Okay, forget about the fourth group here. Just check, okay, how is our I direction is rotating from the first to second and the second to third. It is rotating in the clockwise manner. And where is the fourth group? Next step is that where is the fourth group? It is on the back side bond. So 4/B clockwise is a R configuration. That's all. That's all. It is having the R configuration here. Understood now? And in case if it is on the backside bond, okay, if it is on the backside bond, then what to do? Okay, let me tell you that here. If it is on the backside bond, you can do it like this here. Okay, for example, let me write one molecule here. Okay, one simple example I am giving you. For example, see, this is a wedge bond, and this is okay flying bond. Okay, right. Here I'm writing something like a aldehyde, and here I'm writing the hydrogen, and there is a hydroxy group, and here is a methyl. Okay, methyl. Okay, this is nothing but lactaldehyde. Okay, lactaldehyde it is. Chiral carbon is here. Yes, of course, this is a chiral carbon. Now give the priority here. Okay, give the priority. So after giving the priority, okay, just follow the same rules here. Okay. So among the 4 directly attached atom, oxygen atomic number is a more. So first, next carbon, carbon, hydrogen. Hydrogen has the least atomic number. So 4th priority, and carbon is attached to, okay, one oxygen with a double bond and one hydrogen, aldehyde group, and it is attached to 3 hydrogen. So since here oxygen atomic number is a more, it gets the next highest priority is a second, and here it gets a 3rd priority. Okay, so 1, 2, 3, 4, done. Now view the molecule, forget about the 4th group here, forget about the 4th group, and then view the molecule from the 1st to 2nd, 2nd to 3rd, how is our I direction is rotating. Okay, from 1st to 2nd and 2nd to 3rd, our I direction is rotating in the anti-clockwise manner, right? It is rotating in the anti-clockwise manner. And 4th priority group is here on the front side bond. Okay, this bond is a front side bond. Okay, 4th priority group is here on the front side bond here. So if the 4th priority group is here on the front side bond, I told you now. So what it is here, if the 4th priority group is here on the front side bond, okay, here, okay, the clockwise rotation is a, okay, yes, anti-clockwise rotation is a R here. Okay, now let's check that here. Okay, if you check that, okay, 4th priority group is here on the front side bond, anti-clockwise is here, so you can say it has a R configuration. The chiral carbon is having the R configuration. Easy now. Now what if it is there at the normal bond? If it is not at the front or back side carbon, if it is at the normal bond, what to do here? Let me tell you that here. Okay, quite simple. Okay, quite simple here. So what you do is that, for example, consider I am writing a molecule like this here. Okay, consider this is the front side bond. Okay, carbon, carbon. Okay, this is the front side bond, and it is a back side bond. Okay, right now you can check that. Okay, what I am doing is that I am writing the hydrogen atom here. Here I am writing the hydrogen. Okay, now, and the remaining groups are there. Anywhere you can write. Okay, let me write the aldehyde here, hydroxy group here, and a methyl group here. Then give the priorities. Okay, that's all. Okay, give the priorities here. How to give the priorities here? Okay, the priorities, okay, you know, follow the SIP rules here. Yes, okay, hydroxy group the first priority, aldehyde is a second, okay, methyl is a 3rd priority, hydrogen is a 4th priority group here. That's it. Now, okay, what to do? So here 4th priority group is not either on the front side, okay, or on the back side bond. It is there on the normal bond. Then what to do? What to do? You know, very simple. Just to do one small thing. Operation is called the rotation. Okay, let me show you that here. Now suppose here see. Okay, you can say yellow color is a, okay, yellow color is a the 4th priority group here. Okay, it is there above the side now. It is there above the side now. Next, what you do is that now just I am imagining one plane in this direction. I am imagining one plane in this direction. So that means these two bonds are the normal bonds. Hold another normal bond. Okay, 4th priority group is there on the front side, the above the side now. Next, what you do? You can rotate it, because rotation never changes the absolute configuration. So you can rotate either in the clockwise direction to bring the 4th priority group onto the front side bond, or you can rotate, okay, onto the back side bond here. That's it. Just to do the rotation. Okay, just to do the rotation. What I am doing is that, okay, if the 4th priority group is here on the normal bond, it may be on the above the side or on left or right side anywhere. So hold another normal bond, and by doing the rotation, bring this 4th priority group either onto the front side or onto the back side bond here. That's it. Okay, just to follow the next rule, you can do that here. Let us do that operation here. If you do that operation, okay, what do you do is that, so now here since the 4th group is here on the, okay, normal bond above this side, I am going to hold this here. I am going to hold it means it will be in the fixed position, right? Aldehyde group is in the fixed position. Okay, let it be here. Okay, aldehyde is there at the fixed position. Okay, aldehyde is there at fixed position. Let it be here. Let me do that operation. Okay, what I am doing here is a carbon. I am holding the aldehyde here itself. Okay, so rotate it. Okay, rotate it. Okay, where you want to bring 4th priority group onto the back side bond or front side bond, that is your wish, no problem. So let me rotate, okay, to the back side here. That means, okay, I have to rotate up to here, and whenever I rotate here, this will comes here, and this group will goes here. Okay, that's it. Okay, now, so here the positions of the bonds will not be changed, but by this rotation, positions of the groups will be changed here. Okay, bonds will be at the same position, but the groups only will be changing their position. Now what I am doing, I am bringing the 4th group, okay, to the back side, hydrogen. Then that hydroxy group, okay, back side hydroxy group comes front side. So here will be the hydroxy, okay, and then the, okay, this methyl group goes above this side here. That's all, simple. Now you can follow the, okay, the rules now. I told you the rules here. You just follow the rules here. What are the rules I told you? Okay, the rule is that, okay, so this is the first group here, and this is a second priority group, and this is third priority group, and this is a fourth priority group here. Now view the molecule from the first to second and second to third here. How is our I direction is rotating? Yes, our I direction is rotating in the clockwise manner. Fourth group is on the back side. So 4 by B clockwise is a R configuration. Yes, that's it. Okay, it is in the R configuration. Understood now? Like this you guys have to assign the absolute configuration by following these rules here. Okay. So this is a way, okay, to assign the absolute configuration at a chiral carbon, whether the molecule may be represented in the Fisher projection formula or whether it may be represented in the wedge flying formula. You just follow these things, guys. Okay, you can assign the absolute configuration here. Next, we have to, the important thing is that we have to go to the applications of absolute configuration. What are the applications of absolute configuration? We can identify, okay, the different molecules, like identical molecules you can identify. You can identify the enantiomers, you can identify the diastereomers, okay, all these things are there. Okay, how to identify with the help of absolute configuration, I will explain in upcoming classes here. Okay guys, thank you very much. So here, let me give you some small announcement here. So, so we are launching this chemistry course from the Harish Academy. Okay, I'm your chemistry faculty, Pavan sir. So here I'm starting the course for the 9,999. Okay, so this from 21st onwards. Okay, the course will be started. This is a live interactive classes. Okay, this is a live interactive classes. Those guys who are missing the live classes, okay, due to some other works and all, okay, we have, okay, here you are having the one facility, that is, okay, our classes will be recorded in our app. Okay, so just download that app. Okay, whatever the recorded classes are there which you missed, okay, again you can listen those classes. Okay, if you have any doubts and all, you can contact us directly. So hope you guys will enjoy, okay, the techniques of chemistry by Pavan sir here. Okay, thank you guys, bye, take care.